Okay, so right now we're going to do a little bit of rapid fire problem solving. And we're going to start off with a basic problem. And one thing that we're going to do is take advantage of independent segregation. So we're not just going to talk about the patterns of inheritance of one set of chromosomes. We're going to talk about the patterns of inheritance among 4 different independently segregated chromosomes. Okay. So specifically, I'm going to ask this question. We have 2 individuals that have this particular genotype. Big A, little a. Semicolon, semicolon indicates another chromosome. Big B, semicolon. Big C, semicolon. Big D, little d. And I'm going to cross this with an individual that has this genotype. Big A, little a, another chromosome. Big B, little b. Okay, big C, little c, and big D, little d. And I'm asked a slightly tricky probability question. I'm going to ask, what is the probability that we do not get in any given offspring? That's the not signature. An individual that is basically homozygous for the recessive allele for all the different alleles. Okay. Probability little a, little b, little c, little c, and little d, but not that. So everything else, but not that. Now, it would be tricky to calculate all of the different ways that you can get not that. Okay. But one trick I want to show you using the law of total probability is that one way of calculating not something is to calculate what that something probability is, and then just doing a 1 minus. So this, of course, because of the law of total probability, would be simply 1 minus the probability of in fact getting this. Okay? So we can use that trick to calculate what this in fact is. Okay? So what is this probability? Okay. Well, we have to consider independent events, okay? And so the segregation pattern, because of independent segregation, okay, is independent for what alleles are transmitted from this individual and this individual, this individual chromosome, doesn't bear on the inheritance of the other chromosomes, okay? So what you can do is to calculate the probability, you can just basically multiply the probabilities of independent segregation for each set, okay? So what you're going to do is you're going to basically break it down, and you're going to say that this is equal to the probability of inheriting little a, or well, 1 minus the probability of inheriting little a times the probability of inheriting little b times the probability of inheriting little c times the probability of inheriting little d. Okay? So what is, let's plug in some numbers, okay? So what is the probability of being little a for this particular set of alleles? Okay, well, it's this basic Punnett squared, so it's a quarter, right? So 1/4. Okay, what's the probability of being little b? Well, actually, you can see that it's impossible, right? So you just can say 0. Okay, for that. Okay, and then you could also say, what's the probability of little c? Now, of course, once we put a 0 into this, the whole thing just becomes a wash. But you can actually just complete this then, just for the sake of completeness. So it's probably a little c, well, that can't happen. Okay, and the probability of little d is a quarter. Okay, so this, of course, then is 1 minus 0. Okay, but you can see that you can actually, so this probability of not being this is in fact equal to 1. But you can see how doing this type of thing can actually give you complex probabilities in this fashion.